So we'll go to the next important and a nightmare topic. No, for many, right? So we'll go to this functions. So thing is, it's actually an extension of what you have learned in your 11th grade. That is why I put no rewind. We'll recap and then we'll see what we discussed in 11th standard, try to understand those basics first, and then we'll go to 12th standard. Okay. So if you observe a pattern in relations, right? When you were in your 11th grade, you try to understand what were relations. And in 12th grade, we try to understand what are the different types of relations, like reflexive, symmetric, and transitive. And the last one, which is called as the equivalence. We try to understand the properties of it, right? So it's basically coming only from one thing. You give an input, what is the output you're getting, and how are those two related? Am I right? So the whole language is in terms of only two things. What is it? For whatever input you give, what is the kind of output you give? Suppose if I speak in terms of relations, just to recollect the concepts. If you give the input and you get the same output, what kind of a relation do you call it as? You call it as a reflexive one. You give one input, right? You get an output. If you reverse it, means if the output becomes the input and the input becomes output, it's called as the symmetric. Then you give one input and one output, right? And the output of the first set will become the input of the second set. So A comma B, B comma C. And what do you actually get? You get the input from the first set and the output from the second set as an ordered pair. You call it as a transitive. So it's the same thing. I could have used A, B, B, C, but I'm just giving you another version to visualize it. I hope you're able to see it, right? What I'm trying to say. Imagine the same kind of thing, right? Now we are going to extend the concept of these relations to something called as functions. So if you see, functions are not something that are completely different from relations. Functions are actually relations. They are special kinds of relations which follow a very, very important property, right? Which exhibit a very, very important property. If that property is exhibited by that particular operation, then you can call it as a function. Sorry, by that particular relation, you can call it as a function. So what is that actually? So if you see, if you are able to define a relation, right? If you are able to define a relation, and what is the name you given to that relation? So instead of R, we call it as F, right? If you define a relation F from one set to another, what are the two sets? Set A to set B, then you can call it as a function, provided every element that is there in the set A has one and only one image associated in set B. Are you able to understand what I'm trying to say? So having said this, let's first try to understand what they're trying to tell from this definition. So what do we basically have? I'll give you two sets, A and B. Obviously, both the sets are going to be non-empty sets. They contain some elements. For example, let me take this as x1, x2, so on till xn. Similarly, I have y1, y2, so on till yn. Right? So let's say x1 is related to y1. x2 is related to y2, right? x3 is also related to y2, for instance. Okay. And xn minus 1 is there. No, xn minus 1 is related to yn. Right? Can you call this kind of a relation as a function? Can we call this as a function? Why? Read the definition carefully. I told you x1 is related to y1, x2 is related to y2. Till that, which is the last element that is associated to an element in set B? xn minus 1. I didn't speak anything about xn. Xn, I didn't draw an arrow mark also. Now, can I call this as a function? Range of A and B doesn't make sense. I'll come to that range. Range in the sense you're trying to say the number of elements. That's not the thing. Is this a relation or not? Read the definition and see. Every element. What is it we are trying to say? I spoke about all the elements, but I didn't speak anything about xn. Since xn does not have any element as an image in set B, there's not a relation. So every element in set A should be associated to some element in set B. Whether it is a unique element, different element, that's a different story. What do I mean by unique element? X1 is connected to Y1, whereas X2 and X3 both are connected to Y2. It's not a unique element, right? That is a different story. But for it to basically be called as a function, what is the first thing that it needs to satisfy? That relation should satisfy the condition that every element in set A is associated to some element in set B. If that is failing, that is not a function at all in the first place. Am I clear with this? So that is why I stressed on the point every element. Okay. What is the alternate definition for it? That is one thing. And it should have one and only one image, right? So till now I was stressing on the point every. Now, if I define the relation like this, x1, x2, so on till xn, y1, y2, so on till yn, for instance, let's say same number of elements. If I take x1 is related to y1, x1 is related to y2 also, and all the elements are related. All the elements are related, but what is happening is x1 is related to y1 and x1 is related to y2 also. Can I call this as a function? Why? Because every element in set A should be associated to a unique element in set B. If it is associated with more than one element, it will not be a function, it is only a relation. So for that relation to become a special kind of a relation called as function, every element should be associated like how we discussed in this case. If at all every element is associated, every element should have only one element that is associated. They can be repetitive elements also, that is not a botheration. We are not bothered about it. But one element should have only one image. So to put it in simple, what is it you're going to do? If I have to write this in the form of ordered pairs, right? So when I write this in the form of ordered pairs, here what will I write? x1 comma y1, x2 comma y2, x3 comma y2, like whatever I defined here, right? So on till I'll have what the last element as x of n minus 1 comma yn. So in this case, it is failing to be a function because xn does not have an image. In the second case, if I write it in the ordered pair set, sorry, in the form of ordered pair, right? So what will I get? I'll have x1 comma y1. I'll have, for the way I considered, I'll have x1 comma y2, and then I'll have x2 comma y2, so on till xn comma yn. One thing is every element has an image, but what is happening? The first element has two images. Because of this reason, it is not called as a function. And that is what the second definition says. A function f is a relation such that no two pairs have the same first element. So they should not have the same first element. If they have, no, it's not a function. I hope both the definitions are clear, right? So both the definitions I took from your NCERT only, right? This is what they exactly say. And what are they? So how do you represent it? So if I take the function f, which is mapped from the set x to set y. So how do you read it? So it is a function that is mapped from set x to set y, where the set x is given a name called as domain. So basically, x is called as domain. And one common mistake is many people think that y is a range. It is not range, it is codomain. What is range? We'll see. Okay, that is one common mistake I've seen people doing. Right? Y is not called range, it's called as codomain. Right? Now, this is what the book definition says. Okay. Now we'll try to understand what is this domain in the first place. So what is domain? If you write in the, sorry, anybody wants to tell me. First element. Is it only the first element? You take all the first elements in the ordered pair and write it as a set. Right? So this is also one point which people miss. For example, in this case, can I say that the domain is x1 to xn minus 1? No. So domain is basically all those input values. It's very simple. The set which is there on the left hand side, it's called as the domain set, or to put it simple, it's called as the input set. Because that is where the elements are coming from, and this is the output set. Right? So if you take the input set, for every input that you give, right? For every input that you give, if you get a finite value, what do I mean by finite value? I should not get infinity or something, right? Then those kind of input values which give a finite output is what is called as the domain set. I'll come to that when we discuss about the numericals. Discuss the numericals, okay? I hope it is clear, right? You're able to understand what I'm trying to say. So X is called the domain of F and Y is called as the codomain. Given that if you take every element in the set X, right? If you take the element small x, which belongs to the set capital X, there is a unique element Y in the set Y that is related to this X, okay? So the unique element Y, you're talking about the unique element, no? This unique element, for example, Y1, Y2, whatever you call it. That unique element is there, no? Right? So that one, you call it as image, obviously. See, this is very basic, which you know from your 11th grades. Now, if you take the set of all those images, right? The set of all values of the images that are formed from the output set is what is called as range. So where does the range come from? Range comes from the codomain set. Domain obviously comes from the first set. I hope you are able to visualize it, right? Please register this in your mind. So set of all values of f of x taken together is called as the range of f or image of x under the operation called as, that operation is basically the relation. I hope it is clear, right? So how do you write it? This is the way we write it. Range of f is equal to every element of y that belongs to the set capital Y, where y is equal to f of x, means those elements which are participating in that relation is what is the range. Okay. So till here, are you able to get some perspective? Are you able to recollect what you would have seen? Right? So after this basic, right, there were some other concepts which you learned in your 11th grade. Right? So you learned about the different types of functions, but what were those functions? They were mathematically called as an identity function, constant function, polynomial function, right? You have rational function, modulus, signum, etc. You have trigonometric functions, right? So how do you write them? For example, if it is a constant function, how do you write? You write it as y is equal to x. So you write this function as y is equal to x, or you'll write it as f of x is equal to x. Are you able to understand this? Am I clear? So how is that f defined from? F will be defined from real numbers to real numbers. So what is the meaning of this? What does this R stand for? Just now I told you it is the
domain.
It is a domain. This is the
Codomain.
codomain. Are you able to understand what I'm trying to say? So f is mapped from R to R, meaning if you give any real number as an input, you get a real number as the output. That is the meaning. Then what about a constant function? Y is equal to, you'll write it as some c or some k, whatever it is. So what is that? How do you, where is the function defined from? So it can be from any real number to any real number, because we don't know what that constant value is. The constant value can be any real number. Are you able to understand? So similarly, you have polynomial functions. So where you say y is equal to a naught x power n plus a1 x power n minus 1 plus so on till an. Right? Then you have a rational function. Basically, what is a rational function? A polynomial function divided by another polynomial function where q of x should not be equal to 0. This is something you would have learned in your 10th grade also. There you learned in real numbers as rational numbers. Rational number is a integer by integer, which are co-primes. Whereas rational function is polynomial function by polynomial function, where the denominator polynomial function should not generate a 0. Right? So what about modulus function? Y is equal to mod x, right? Then you have the signum function and all such functions. Okay. Next is, you would have also learned the basics of addition, subtraction, multiplication, and division of functions. So when you talk about division only, you get this rational function. When you talk about multiplication, you get this kind of function. Means a real number is multiplied with a variable. You're able to understand? So with this, your 11th standard basics are over. Now the next question is, what are we going to learn something different in our 12th standard? Right? That is what we need to understand. So if you come to the same concept of functions for your 12th standard, like how we discuss the different types of relations, we'll be discussing the different types of functions, where those functions are categorized based on how the input and the output are going to be connected. So first thing is they need to satisfy the condition of being a function. That we will not do any check. Right? We will directly say if there is a function given to us, we need to find whether the given function is a 1-1 function, or it is an onto function, or it is both 1-1 and onto, which is called as bijective. Okay. The other name for 1-1 function is injective. Okay. Second is the other name for onto function is surjective. And the combination of these two, 1-1 and onto put together, is called as bijective, which is combination of injective and bijective. This is very, very, very important. Without this, we cannot understand inverse trigonometric functions. That is the next chapter. Or you cannot understand calculus. If at all in any of your schools, right, if they are starting directly with your calculus and just giving you the formula or something, it is not going to last forever. I would like to conclude this statement. Some places they do it. Either they'll start with matrices and determinants. Okay, it is fine because it is independent. It's algebra. Whereas if you're directly starting with continuity and differentiability without functions, calculus doesn't make sense. Right? For that, these basics are very, very, very important. As I told you, I'm not denying the fact that this chapter is tricky, but if you practice, you can master. Only thing is concentrate on the basics and the important parts. Right? So is it clear till this time? Right. Shall we see one by one in detail? No, it's not some. It should be both injective. Oh, it's surjective. Sorry, I made a mistake. So it should be injective and surjective. Yeah. So it should satisfy both. Okay. So this is very, very, very important for us to understand why inverse of a function exists. So are the things registered in your mind? Right. So I'm not showing you the previous 3 slides. From here, can you copy? So if you want, you can have your textbook also open. I think page number 7, no? Page number 7, you have the heading called as types of relations. Okay.